welcome to my first lecture of electrical fundamentals. In this lecture, I will be teaching you the Kirchoff voltage law. So, as in this lecture, I'll be doing much of the talking and less of the writing. So, if you want to understand, you better write down the definitions as I go along. Kirchoff's voltage law. Kirchoff's voltage law is one of the fundamental laws used in circuit analysis. It is useful for finding potentials in currents where insufficient data is given, or not insufficient data where the simple analysis is not possible. It is one of the many contributions of the German physicist Gustav Robert Kirchhoff. He was alive in the mid 80s, in the mid 1800s, I'm sorry. So, Kirchhoff's voltage law. Kirchhoff's voltage law states that the algebraic sum of all the voltages of all the branch voltages at any time instant around any closed path of a network is zero. Now, what do you understand by a branch voltage? A branch voltage is a voltage across a cell, resistor, or any other component. It may be a battery, it may be a resistor, it may be a load resistor, it doesn't matter. Okay, now to understand this law, we'll look at a simple circuit diagram. Now I'll be doing the writing. Okay, so this is the diagram. It has a battery. This is the load. So load, you may call this as L1, and second load L2, and third load L3, and this is the battery. This plus and minus. So imagine that the battery gives voltage of VA. The voltage is VA, and the voltage across the load resistance is V1, V2, V3, which is in load L1, L2, L3 respectively. So according to the law, VA, V1, V2, V3 will be 0. I'll write it down. According to Kirchhoff voltage law, VA minus V1 minus V2 minus V3 is equal to 0. So how do you prove this? Okay, as you know that current, when it moves through the load resistance, it becomes negative. So it starts from positive in this direction, it comes here, it becomes negative, it becomes further negative, it becomes further negative, and then finally, according to the law of conservation of energy, it becomes 0 when it finally reaches here. So imagine a charge Q is flowing through the network. The charge Q, it starts from here, goes this and all that. Okay, since the battery, it gives the positive charge, and as the charge Q picks up to the first load resistance L1, it becomes negative, which is minus V1, and when it reaches here, minus V2, reaches the third, minus V3, and finally to 0. Now, so energy, now we calculate for the first load resistance for the cell, it is Q into VA. For the first load resistance, first load resistance, Q into minus V1, second Q into minus V2, third Q into minus V3. Now what we do is we add all these up to get, and as I told you, according to law of conservation of energy, when the charge finally reaches back to the negative end, it becomes 0. So according to the law, Q into VA plus q into minus v1 plus q into minus v2 plus q into minus v3 is equal to 0. Now we divide the equation by q. What do we get? Va minus v1 minus v2 minus v3 is equal to 0. And this is what the law is. This is the Kirchoff's law. Now, this law is very useful, as I said, in circuit analysis and can be applied to infinite number of loops. Here, there was no loop. This is one single loop. However, if I wanted a loop, I could have taken two of them. Call this as loop 1, loop 2. These are example with two loops. I could have taken three loops. Loop 1, loop 2, loop 3. Now how to solve the equations in Kirchoff's law, applying the Kirchoff's law, that I'll be taking in another lecture. So if you like this video, please do not forget to like and subscribe, and I want to make one more point over here. When you take this as positive and this as negative, it doesn't mean that the bigger end, the battery, which is indicated by this, is always positive. You could have taken this as negative and this as positive, but once you take this as negative and this as positive, you cannot change it in your sum. You have to carry on using this as negative and this as positive. Like in this case, I took this as positive and this as negative. So now if you like this video, please do not forget to like and subscribe, and if you have any doubts for this lecture, you may reply in the comment section below, and thank you.